Today's video is about vectors. One of my students asked me to make this video for her, so here it goes. Vectors, they have a magnitude and they have a direction. So when it comes to adding two vectors, we really need to be careful, because if I have a vector, if I had two quantities that are just 3 and 5, like 3 pieces of candy and 5 pieces of candy, then the total would be 8. This doesn't usually work for vectors, so let me show you how we add vectors. Again, a vector has a magnitude and has a direction, and so if this is a vector, we call this a tail, and we call this a tip. Some other people call this a head, but the tail, we always call it a tail, okay? So this is it. Now, let's say I walked 3 kilometers towards east, so this is 3 kilometers, and then I went 4 kilometers due north, so this is the 4 kilometers due north, and then I want to know my total displacement with respect to the origin here. So this is, am I going to say 3 plus 4, 7? No, this is not correct, because these two vectors, they do not have the same direction. So how do we add them? So we go from the tail of the first vector to the tip of the second vector. You see here, our first vector, its tail, its tip. Then we place the tail of the second vector with the tip of the first, and then so the resultant, or the vector sum of these two vectors, is just going to be like this. Okay, so this is R. R for resultant or sum. Okay, so this is how we get it. Then you see here, the tip of the resultant coincides with the tip of the first vector, and the the tail of the resultant corresponds with the tail of the first vector, and its tip coincides with the tip of the second vector. Okay, I hope I did not confuse you, but it's clear here in the figure here, or in the diagram. So in this case, we have a 90 degrees angle, and 90 right triangles are very easy to deal with. So usually when you have a triangle that has a 90 degrees, and then this is leg 1, this is leg 2, and this is the hypotenuse, we know by virtue of the Pythagorean theorem that the hypotenuse squared equals leg 1 squared plus leg 2 squared, and then the hypotenuse is just going to be the square root of the sum of the squares of leg 1 and leg 2. So hypotenuse squared equals leg 1 squared plus leg 2 squared. If you don't like legs and hypotenuse, we usually call this A, B, and then C. So we just say C squared equals A squared plus B squared. So here, this R squared is going to be 3 squared plus 4 squared. So R is going to be the square root of 3 squared plus 4 squared. That's the square root of 9 plus 16, square root of 25, 5. And my dear students, really, in exams, I really want you to know the right triangle that is 3, 4, 5. This is like in math, in physics, it's very, very useful to know some special or some specific triangles, right triangles, and this one is really easy. It's just 3, 4, 5. So the two legs are 3 and 4, and then the hypotenuse is 5. And that's the reason why I chose this example, so I don't have to use a calculator. So now they tell you, okay, so did we find 3 plus 4 like 3 plus 4 equals 7? No, we found the 5. So this is of crucial importance. You have really to pay attention on how to add vectors. They are not usually added like scalars, which are quantities that only consist of magnitude. Okay, so now the second question is they are going to ask you, what is the angle? What is this angle? And usually we use Greek alphabet, you know, theta, beta, whatever. So we use theta here. And then, so what is this angle? What is this opening? We are going to be using, what is tan theta? Just to recall some trigonometric ratios. Maybe I should also make a video about the unit circle. Cosine theta, or SOHCAHTOA, is the adjacent over the hypotenuse. Sine theta is going to be the opposite over the hypotenuse. And finally, I mean, just for now, for grade 9 and grade 10, tan theta is also a ratio, and it's going to be the sine over the cosine, or it's just going to deal with the legs, so it's going to be the opposite over what? Over the adjacent. So, and what you're going to use in this lesson when they ask you to determine the the direction, they're asking you to get the theta. So what are you going to do? On your calculator, you are going to use 10 minus 1, or arc10, the inverse function of theta, and of the opposite over what? Over the adjacent. So in this case, you are going to say arc10, or 10 minus 1, so that's the inverse. What is the opposite that the angle is looking at? It's 4. And what is the adjacent? The neighbor is 3. So we're going to find approximately 53 degrees. So basically, this is what we do when we have a right triangle. I'm going to show you the more general case when the vectors that we want to add do not make an angle of 90 degrees between them. It's not a very complicated formula, and it can be actually very, very useful. Okay, so let's erase this board. Okay, so imagine that I walked 3 kilometers due east, and then I walked 3 kilometers, but then the angle here is different from 90 degrees. The angle here is more than 90 degrees. Okay, so the resultant is going to be, again, from the tail of the first vector to the tip of the second vector. Okay, so this is the resultant. Okay, and this resultant R is going to have a magnitude, okay, is going to have a magnitude that is given by this formula. So if we have a triangle, let me draw a triangle here. Okay, so if we call this side A, and this side B, and this side C, we have a convention of calling the angle that's facing A, capital A, and then the angle that's facing side B, capital B, and then the angle facing side C, we call it capital C. And we have 3 very beautiful formulas, but again, I'm crazy about math and physics, so if you don't like the formula, that's fine. C squared is going to be a squared, oh, sorry, C squared, I'm not talking about angles here. C squared is a squared plus b squared minus 2 times a times b cosine b angle c. So c squared, you've got cosine c, and then you've got a squared plus b squared minus 2 times a times b times cosine c. So if I'm looking now, let's say I'm looking for a, let's see if you can do this. What are the remaining sides? If I'm considering I'm looking for side A, the remaining sides are B and C. So you've got it. It's going to be B squared plus C squared minus 2BC. That's British Columbia. I love British Columbia. It's beautiful. And then cosine what? Cosine A. Cosine A. Let's do it one more time for side B. So we're going to have B squared. What are the two remaining sides here? A and C. You've got it. You are a genius. So A squared, okay, plus C squared minus 2AC, okay? Cosine what? Cosine times cosine B. So this is going to be your bread and butter for vectors. Let's see if we have a right triangle, then cosine C is going to be cosine 90 degrees. What's cosine 90 degrees? It's going to be 0. Those of you who don't know it, just go to your calculator and write cosine 90 degrees. Make sure that your calculator is in degrees mode, and then, so you're going to end up with the Pythagorean Theorem. So the Pythagorean Theorem actually is a special case of this more general formula. So here, I'm just going to give you an example. Let's say we've got 120 degrees here. So r squared is going to be 3 squared plus 3 squared minus 2 times 3 cosine what? Cosine the angle that is facing this side, which is 120 degrees, okay? And then you just go to your calculator and take the square root of 9 plus 9, which is 18, minus here 3 times 3, 9 times 2, again it's 18, cosine 120. Okay, I do not have a calculator by my side, and I do not want to go through the calculation, but I hope that you got the idea. So that's how we add vectors. Now we have, oopsies, I'm going to summarize everything later. You could go back to it. So this is it. This is very, it's called the cosine rule. We also have what we call a sine rule, and a sine rule will help you, cosine rules and sine rule will help you solve a triangle. Solving a triangle means determining the size of all the sides and determining the size of all angles. You know that the sum of the angles in a triangle is 180 degrees. Okay, so this is it. If let's say I went 3 kilometers due east, and again 4 kilometers due east. This is the only case where I'm just going to add them, because you see the direction is the same, and then we're going to use the same rule, the tail here of the first vector, and then the tip of the second vector. So this, and then I have 7 kilometers. This is the only case where you add them, just like you have 3 pieces of candy and 4 pieces of candy, you know. Only case, okay? If let's say I go 3 kilometers due east, and then I come back 4 kilometers due west. This is not to scale, and this is not the most beautiful vector. So we're going to apply the tail of the first vector to the tip of the second vector, or to the head of the second vector. So this is going to be 1 kilometer due what? Due west. So hopefully this clarified calculations about vectors for you. If you have any questions, please ask them, post them, and I'll do my best to answer every single question. As a reflection or a summary, if you've got two vectors, this is how we add them, A, B, then the resultant, or C, the tail of the first vector is going to correspond to the tail of the resultant. We bring the tail of the second vector to the tip of the first, and so the tip of the resultant is just going to also coincide with the tip of the second vector. And then this angle here, if it is called C or theta or whatever, the r squared is going to be a squared plus b squared minus 2ab cosine this angle, if you want to call it theta, is theta. So this stems from when you have a triangle ABC, ABC, a squared, what are the two other sides? B squared, sorry, plus C squared minus 2BC, again British Columbia, cosine what? Cosine A. You see the side that you're looking for with the angle that is opposite to it. B squared equals A squared plus C squared minus 2AC cosine B, and C squared equals A squared plus B squared minus what? Minus 2AB cosine C. I hope that this clarified some of the concepts about vectors and how to add them. You can only add them like you add scalars if they are in the same direction, if the angle between them is 0. If one is going east and the other is going west, we're gonna subtract them basically. Okay, so this is it. I will see you in another video.